Hello everyone, very warm welcome to DMG chemistry classes, and in today's video I am going to discuss a very interesting and important experiment, and the experiment is to determine the distribution coefficient of iodine between carbon tetrachloride and water at room temperature. And in my previous video I discussed Nernst distribution law, and I also told you what is distribution coefficient or partition coefficients. So friends, iodine exists in same molecular form in both the solvents. So the distribution coefficient of iodine will be calculated with the help of this formula, that is concentration of iodine in CCl4 layer divided by the concentration of iodine in water layer. So this is the formula for the calculation of partition coefficient of iodine. And now let us discuss the requirements of this experiment. So the apparatus required are, we will require 4 250 ml reagent bottles with stoppers, and stoppers will be of glass. Okay, then burette, pipette, titration flask, then measuring cylinder and separating funnel. So these are the apparatus required. And chemicals required are iodine, carbon tetrachloride, 10% solution of potassium iodide, N by 10 and N by 100 sodium thiosulfate solutions, and starch indicator. So these are the requirements of this experiment. Now let us discuss the procedure of this experiment. And in the very first step of this procedure, we will prepare a 2% solution of iodine, and it will be prepared by dissolving 4 gram of iodine in 200 ml of carbon tetrachloride. So the first step of the procedure is preparation of 2% solution of iodine. As I said, we will dissolve 4 gram of iodine in 200 ml carbon tetrachloride. And in second step, we will take 4 glass stoppered reagent bottles. Okay, then we will wash these bottles with water and dry them in an electric oven. So here, let us suppose that these are the 4 glass stoppered reagent bottles. Okay, and then we will label them as 1, 2, 3 and 4. So let this is the first reagent bottle, then second, third and the fourth. Okay, and in the next step of the procedure, we will prepare solutions in these reagent bottles, and the procedure for the preparation of these solutions will be, and the procedure will be explained with the help of a table. So here we will have your bottle number, then volume of iodine solution added, and it will be in ml, then volume of CCl4 added, it will also be in ml, then volume of water added, and then finally we will have total volume. Okay, so in the first reagent bottle we will add 40 ml of the iodine solution which we have prepared in the first step. So in first reagent bottle we will take 40 ml of iodine solution, and in this bottle we will not add CCl4 solution, sorry, CCl4. Okay, and in this bottle we will add 100 ml of distilled water, and the total volume will be equal to 140 ml. Okay, and in second bottle we will add 30 ml of iodine solution and 10 ml of your carbon tetrachloride, 100 ml of water, and the total volume here again will be equal to 140 ml. In third bottle we will have 20 ml of iodine solution and 20 ml of CCl4 will be added to it, 100 ml of water, and 140 ml is the total volume. And in the fourth and final bottle, 10 ml of your iodine solution, 30 ml of your CCl4 and 100 ml of water, and total volume is equal to 140. Okay, so in this way we will prepare the solutions in different reagent bottles. Now what we will do in the next step, we will shake these reagent bottles vigorously, or we will shake them either manually or with the help of an electric shaker. मतलब इसके बाद जब सॉल्यूशन बन जाएंगे तो जो हमारी 4 रिएजेंट बॉटल्स होंगी उनको हम शेक करेंगे विग्रसली, काफ़ी ज़ोर से उनको शेक करेंगे। और जो शेकिंग होगी वो मैनुअली भी हो सकती है। उसमें हम क्या करेंगे, जो हमारी रिएजेंट बॉटल्स हैं उनको एक रबर ट्यूब के साथ बांधेंगे और वी विल शेक देम ऑन द बेंच। ओके, so this is a manual shaking, and we can also shake these bottles with the help of a mechanical shaker. And after shaking these bottles vigorously, we will allow these bottles to stand undisturbed for 15 minutes, and the shaking will be for 30 minutes. Okay, we will shake these bottles for the 30 minutes or half an hour, and after shaking we will allow these bottles to stand for the 15 minutes undisturbed. फिर 15 मिनट तक हम इन बॉटल्स को अनडिस्टर्ब्ड रखेंगे, सो दैट द CCl4 लेयर एंड द वाटर लेयर सेपरेट्स आउट। फिर जब हम इनको 15 मिनट तक अनडिस्टर्ब्ड रखेंगे तो हर बॉटल में 2 लेयर्स बिल्कुल साफ बन जाएंगी। ओके, एक लेयर होगी आपकी जो अपर लेयर होगी, दैट विल बी योर वाटर लेयर और एक्वस लेयर, एंड द lower layer will be your CCl4 layer. And due to this vigorous shaking, some iodine will be transferred from the CCl4 layer to the water layer. जब हम vigorous shaking करेंगे तो जो आयोडीन है वो ट्रांसफ़र हो जाएगी आपकी CCl4 लेयर से एक्वस लेयर में। तो इस तरह से जो आयोडीन है it will be distributed between both the solvents. Okay, and after this step we will separate the aqueous layer of each bottle from the CCl4 layer, and the separation will be done with the help of a separating funnel. ठीक है, तो let us explain that how do we separate these aqueous and CCl4 layers with the help of a separating funnel. So let us explain it diagrammatically. So here we have a separating funnel. It will be like this. Okay, and it has a knob here, and what we will do, we will transfer, okay, we will transfer the solution in the bottle number 1 in the separating funnel, and in the separating funnel again the 2 layers will be formed. So the bottom layer or the lower layer will be of your carbon tetrachloride, and the upper layer will be your aqueous layer or water layer. Okay, and then we will open the knob of this separating funnel, and we will collect, okay, we will collect the CCl4 layer in the beaker or in conical flask. Okay, and after the separation of this CCl4 layer, we will turn this knob off, and we will remove this beaker from here. So in this layer in this beaker we will have your CCl4 layer. Okay, then we will again open the knob of your separating funnel, and after this we will collect the aqueous layer in another beaker. So in this way the two layers of the bottle number 1 will be separated with the help of your separating funnel. So in this way the aqueous layer and the CCl4 layer of each bottle will be separated. And now I will explain the procedure for the bottle number 1, and the procedure will remain same for the rest of the 3 bottles. Okay, and in the next step of the procedure, what we will do, we will titrate the CCl4 layer of your bottle number 1 with N/10 sodium thiosulfate solution. So next step is titration of CCl4 layer of your bottle number 1 with N/10 sodium thiosulfate solution. Okay, and the procedure for this titration will be, first of all we will rinse and fill the burette with N/10 sodium thiosulfate solution. तो हम एक ब्यूरेट लेंगे, इस ब्यूरेट को रिंस करेंगे आपके सोडियम थायोसल्फेट सॉल्यूशन के साथ ही, और फिर फिल करेंगे इसको N/10 sodium thiosulfate solution से, and then we will note its initial reading. Okay, after this we will pipette out 10 ml of CCl4 layer of bottle number 1, okay, in the titration flask. Then we will add to it 10 ml of 10% solution of potassium iodide. तो हमने टाइट्रेशन फ्लास्क में क्या लिया, 10 ml लिया हमने CCl4 लेयर का बॉटल नंबर 1 का, और उसमें हमने 10 ml और ऐड कर दिया पोटाशियम आयोडाइड का सोल्यूशन, 10% solution of potassium iodide. Okay, and after this we will start the titration. We will titrate the solution taken in the titration flask against this N/10 sodium thiosulfate solution taken in the burette. फिर हम titration शुरू कर देंगे, and we will titrate it till the appearance or the color of the solution becomes pale yellow. फिर हम titration जारी रखेंगे with constant shaking. और हम कब तक टाइट्रेट करेंगे इसको, हम इसको तब तक टाइट्रेट करेंगे जब तक हमारे जो सॉल्यूशन का कलर है वो पेल येलो हो जाएगा, लाइट येलो हो जाएगा. और जब ये स्टेज आ जाएगी, देन वी विल ऐड 1 ml ऑफ फ्रेशली प्रिपेयर्ड स्टार्च सॉल्यूशन इनटू इट. फिर इसमें हम 1 ml स्टार्च सॉल्यूशन ऐड कर देंगे जो हमारा इंडिकेटर रहेगा, एंड द कलर ऑफ द सॉल्यूशन विल टर्न ब्लू, और इस सॉल्यूशन का कलर जो है वो ब्लू हो जाएगा. ठीक है, जब ये सारा स्टेप हो जाएगा, देन वी विल अगेन स्टार्ट द टाइट्रेशन. ओके, वी विल स्टार्ट एडिंग दिस N/10 सोडियम थायोसल्फेट सॉल्यूशन फ्रॉम द burette ड्रॉप वाइज टिल द कलर ऑफ द सॉल्यूशन बिकम्स कलरलेस. और फिर हम तब तक टाइट्रेशन जारी रखेंगे जब तक हमारा जो कलर है सॉल्यूशन का ब्लू से वो कलरलेस नहीं हो जाता. And this will be the end point of our titration. Then we will note the final reading of the burette, and we will calculate the volume used by subtracting your initial reading from the final reading. And we will repeat this procedure to get 3 concordant readings. तो हम इसको repeat करेंगे procedure को ताकि हमारे पास 3 concordant reading आ जाए, या 3 concordant volumes हमारे पास आ जाए. If all the, because we will have 3 volumes here, and if all the 3 volumes have same value, अगर तीनों volumes की same value है, then that value will be the concordant volume. And if the 2 out of the 3 have the same value, then that same value will be the concordant volume. Okay, so then here we will have the concordant volume, and the same procedure will be followed for the rest for the aqueous layer of all the 3 bottles also, or the rest of the 3 bottles. जो बाकी बची हमारी 3 bottles हैं, उनकी aqueous layer को टाइट्रेट करने के लिए भी यही प्रोसीजर फॉलो किया जाएगा. Okay, then after this we will titrate the water layer of bottle number 1. So now the titration of your water layer of bottle number 1 with n by 100, okay, n by 100 sodium thiosulfate solution. ठीक है, अब हम क्या करेंगे? In this step again we will rinse and fill the burette with n by 100 sodium thiosulfate solution. तो यहाँ पर अगेन हमने burette में फिर से ये n by 100 सोडियम थायोसल्फेट सॉल्यूशन ले लिया, फिल कर लिया burette को, and we again noted the initial reading. Then what we do? Then we take 10 ml of aqueous layer. Aqueous layer या water layer का 10 ml हम लेंगे टाइट्रेशन फ्लास्क के अंदर. Then we will add 5 ml potassium iodide solution to it. Okay, and 1 ml of starch indicator. So here the starch indicator will be added in the beginning, and the color of the solution taken in the titration flask will turn blue. Then we will start titration. फिर हम titration शुरू कर देंगे और we will titrate it till the color of the solution changes from blue to colorless. और जो जब blue to colorless हो जाएगा solution, that will be our end point. And here we will repeat this procedure to have 3 concordant readings or to have concordant volume. Okay, and this procedure will be followed for the titration of aqueous layer of the rest of the bottles. जो बाकी bottles होंगी हमारी, उनकी जो उनकी aqueous layer जो होगी उसके titration के लिए भी यही procedure follow किया जाएगा. ठीक है, so this is all about the procedure of this experiment. And then we will note the observations. So in observation, first of all we will record the room temperature. Observation, और ऑब्जर्वेशन में सबसे पहले क्या चीज़ लिखी जाएगी? सबसे पहले लिखा जाएगा रूम टेम्परेचर, और जो भी टेम्परेचर लैब का होगा that will be a room temperature. And then we will draw here the observation table, and it will be drawn like this. Okay, it will be a large observation table. So here we will have bottle number, okay, and here we will have your volume of n by 10 sodium thiosulfate used for 10 ml of CCl4 layer, and here we will have volume of, okay, your n by 100 sodium thiosulfate used for 10 ml of water layer. And here again, as I said, we will have 3 concordant readings and we will have 3 volumes. So first volume in ml, this is second volume, and here we will have third volume, and here we will have concordant volume. Okay, so likewise here also, first reading you have first volume, second, third in ml, and then concordant volume. Okay, so here we will have bottle number 1, bottle number 2, bottle number 3 and bottle number 4. And as I said, we will have 3 values of volume used, and from here we will note the concordant volume, and let the concordant volume for the bottle number 1 is B1 prime, and for the bottle number 2 it is B2 prime, and likewise V3 prime for bottle number 3 and V4 prime for the bottle number 4. And these are the values for the CCl4 layer. And likewise we will have the values for the aqueous layer, and let the concordant volume for the bottle number 1 or the aqueous layer of bottle number 1 is V1 double prime, V2 double prime for the bottle number 2, V3 double prime for bottle number 3 and V4 double prime for the bottle number 4. Okay, so these are the concordant volumes for your CCl4 layer of bottle number 1, 2, 3, 4, and these are the concordant volumes for the bottle number 1, 2, 3, 4 and aqueous layer of each bottle. So this is the observation table. Now we will discuss the general calculations involved, and here I will discuss the general calculations only for the bottle number 1, and the calculations for the rest of the bottles will be same. So here general calculations, for CCl4 layer, for CCl4 layer of bottle number 1. ठीक है, तो पहले जो हम कर रहे हैं कैलकुलेशंस वो बॉटल नंबर 1 की CCl4 लेयर के लिए कर रहे हैं, and let the volume of n by 10 sodium thiosulfate used for 10 ml of CCl4 layer of bottle number 1 is equal to V prime ml. तो यहाँ पे हमने मान लिया कि जो बॉटल नंबर 1 की आपकी CCl4 लेयर है, जिसका हमने क्या लिया था 10 ml पिपेट आउट किया था, उसको पूरी तरह से रिएक्ट करने के लिए जो n/10 सोडियम थायोसल्फेट का कितना वॉल्यूम लगा, V1 प्राइम ml लगा। तो सपोज किया हमने, देन अप्लाइंग द नॉर्मेलिटी इक्वेशन, normality equation is N1V1 is equal to N2V2, and on the left hand side we will have your iodine in CCl4. यहाँ पर हम आयोडीन की कंसेंट्रेशन कैलकुलेट करने जा रहे हैं CCl4 लेयर में, और CCl4 लेयर किसकी? बॉटल नंबर 1 की. तो आयोडीन in CCl4 layer, and towards right hand side we are having sodium thiosulfate solution. Sodium thiosulfate solution. Now we will substitute the values in this normality equation. Now the normality of iodine we want to calculate, so let it is N1, and volume of CCl4 layer which was we pipette out is 10 ml. Okay, and the normality of the hypo solution is N by 10 or 1 by 10, so normality is 1 by 10, and volume used we have supposed it is V1 prime. Okay, so from here we will calculate the normality of iodine in the CCl4 layer of bottle number 1. So normality will be equal to V1 prime divided by 100 normal. Okay, so the normality of iodine in CCl4 layer of bottle number 1 is equal to V upon 100 normal. Then we will calculate the strength of the iodine, and we know that strength is equal to normality into equivalent weight. Then we will substitute the values of normality and the equivalent weight. So the strength of iodine in CCl4 layer, it will be equal to normality, which was equal to V upon 400 into 127 gram per liter. Okay, so this is the strength of iodine in gram per liters, and we can calculate this strength, we can convert this strength into moles per liter by dividing it by the molecular mass of the iodine, because when the weight in gram is divided by the molecular mass, then we have number of moles. So here we will divide by 254, which is the molecular mass of iodine, and then we will have the concentration in moles per liter, and this will be equal to V upon 100 into 127 upon 254 moles per liter. Okay, so this will be the concentration of iodine in the CCl4 layer of your bottle number 1. So the concentration of, and let it is equal to x moles per liter. तो मान लिया कि ये है x moles per liter. So the concentration of iodine in CCl4 layer, okay, CCl4 layer of bottle number 1, that is, इसको हम C1 बोलेंगे, C1, and it is equal to x moles per liter. So in this way we have calculated the concentration of iodine in the CCl4 layer of bottle number 1. Likewise, we will calculate the concentration of your iodine in the aqueous layer or water layer of your bottle number 1. Now we'll write the general calculations for the water layer of bottle number 1. So here we will suppose again that let the volume of N by 100 sodium thiosulfate used for 10 ml of water layer of bottle number 1 is equal to V1 डबल प्राइम ml। तो यहाँ भी हमने सपोज किया है कि जो आपकी बॉटल नंबर 1 की एक्वस लेयर है उसके 10 ml के लिए N/100 सोडियम थायोसल्फेट सोल्यूशन का कितना ml यूज हुआ, V1 डबल प्राइम ml। देन अप्लाइंग द नॉर्मेलिटी इक्वेशन, that is N3V3 equal to N4V4, and here along in left hand side we will have iodine in water layer, and here in the right hand side we will have sodium thiosulfate solution, having normality N/100. So now let us substitute the values in this normality equation. So N3 is the normality of iodine in the aqueous layer which we want to calculate. So N3 we want to calculate, and volume of aqueous layer we have taken in the titration flask is 10 ml. The normality of your hypo solution is N/100 or 1/100, and as we have supposed the volume used is B1 double prime. Okay, and from here we will calculate the normality of iodine in aqueous layer, and normality will be N3, it will be equal to B1 double prime divided by 1000 normal. So this is the normality of iodine, okay, in the aqueous layer of bottle number 1. Now we will calculate the strength of iodine. In aqueous layer of bottle number 1, and as I said, strength is equal to normality into equivalent weight. So the normality is V1 double prime upon 1000, equivalent weight is 127, and it will be in grams per liter. So this is the strength of iodine in the aqueous layer of bottle number 1, and as I said that when I will divide it, okay, by 254, which is the molecular mass of iodine, then this strength will be converted into the concentration in moles per liter, and then let it is equal to Y moles per liter. So this will be the concentration of your iodine in the aqueous layer of bottle number 1. Okay, so the concentration of iodine in water layer of bottle number 1, and it will be your C2, and it is equal to Y moles per liter. Okay, so in this way we have calculated the concentration of iodine in the aqueous layer and CCl4 layer of the bottle number 1, and we will follow the same general calculations to calculate the concentration of iodine in aqueous layer and in the CCl4 layer of the rest of the bottles. Okay, and then again we will record the value of the C1 and C2 in a table. So let us draw the table here. So this will be your table, and again here we will have your bottle number, that is 1, 2, 3 and 4. Then concentration of iodine in CCl4 layer, okay. Then we will have concentration of, and it is C1, okay. Then concentration of iodine in water layer, and it will be your C2. And then here we will calculate the distribution coefficient of iodine or the partition coefficient of iodine, that is K. It will be equal to C1 divided by C2. So here we will have the concentrations of your iodine in CCl4 layer of bottle number 1. Here we will have the concentration of iodine in the aqueous layer of bottle number 1, and then we will divide this C1 by C2 to have the value of K. So this will be the distribution coefficient or partition coefficient of iodine in bottle number 1. And similarly we will calculate the C1 and C2 in the remaining 3 bottles. And if the value of this K, if the value of this partition coefficient or distribution coefficient comes out to be nearly the same in all the 4 bottles, then the Nernst distribution law is proved, is verified. और अगर चारों bottles में, in all the 4 bottles, अगर K की value लगभग same आती है और constant आती है, तो फिर आपका Nernst distribution law जो है वो prove हो गया, वो verify हो गया. ठीक है. And then to calculate the distribution coefficient of iodine, we will take the mean of all these 4 values. We will add these 4 values and we will divide the sum by 4, and that mean value will be the value of partition function or the distribution coefficient of iodine between carbon tetrachloride and water. So in result we will write result. First of all, we will write that the value of your K, that is C1 upon C2, comes out to be nearly constant. Hence the Nernst distribution law is verified or proved. Okay, and in the second step we will write the value of the partition coefficient. So the mean value, or we will simply write the partition function or partition coefficient or distribution coefficient of iodine between CCl4 and water is equal to this much. So we will write the value of a distribution coefficient here, which will be the mean of all the 4 values of the distribution coefficients in the 4 bottles. Okay, so this is all about this experiment, and in my next video I am going to discuss your iodine titrations. Okay, and in those titrations I will explain what is the role of potassium iodide in these titration. I will also explain that why do we add starch solution in the beginning, late in the titration of your CCl4 layer, क्योंकि हम CCl4 लेयर की जब टाइट्रेशन करते हैं तो हम स्टार्च सोल्यूशन को थोड़ा लेट डालते हैं जब सोल्यूशन आपका पेल येलो या लाइट येलो हो जाता है. लेकिन व्हेन वी टाइट्रेट योर एक्वस लेयर देन वी ऐड स्टार्च सोल्यूशन इन द बिगिनिंग ऑफ द टाइट्रेशन. ठीक है, तो ये सारी चीज़ें मैं एक्सप्लेन करूँगा इन माय नेक्स्ट वीडियो. और मैं ये भी एक्सप्लेन करूँगा कि वाई वी यूज्ड n/10 हाइपो सोल्यूशन फॉर द टाइट्रेशन ऑफ योर CCl4 layer and n/100 for the titration of your aqueous layer. So keep watching my videos, like and share my videos and subscribe my channel. Thank you very much.